Your traffic is finally spiking, and suddenly your site crashes. You get a 508 resource limit reached error, and the first instinct is usually panic, followed by buying an expensive server upgrade. The error triggers when you hit your entry process limit, a measure of simultaneous work rather than total daily visitors. Think of the entry process, or EP limit, as a strict concurrency ceiling. It controls exactly how many dynamic PHP requests your server is allowed to process at the exact same millisecond. If all the slots are full, the server rejects the overflow. We are going to verify exactly which limit is failing, plug the invisible drains on your server for free, and map out the exact mathematical threshold where you actually need an upgrade. Go ahead and open your cPanel and WordPress admin dashboards so we can get started. Understanding how concurrency works reveals how a site can stay online during a massive spike without requiring a high-tier server. Step 1 is looking at the exact error code your site is displaying, because the number actually changes depending on your server's architecture. Apache servers immediately reject overflow with a 508 error. Modern LiteSpeed servers queue the request, returning a 503 only if it times out. Despite different codes, both point to the exact same bottleneck. Your entry process ceiling is completely full. To prove this is happening, switch over to cPanel. Scroll down to the Log section and click on Resource Usage. This shows the diagnostic graphs for the exact time frame your site went down. This graph shows the signature of an EP failure. Notice how the entry processes line spikes and hits a hard flat line at the very top boundary, while the CPU and memory lines are still fluctuating safely below their maximums. If you see your memory or CPU graphs pegged at the top instead, you are dealing with a completely different hardware limit, and the fixes we are about to cover will not solve your problem. When the EP graph flatlines while other metrics have headroom, the bottleneck is confirmed as a concurrency event rather than a general lack of hardware resources. Now that we know the problem is concurrency, we can apply the most effective zero-cost fix available, full-page server caching using the LiteSpeed Cache plugin. When a visitor requests an uncached web page, the server has to execute the full WordPress PHP code. That process traps one of your concurrent EP slots for the entire duration of the page build. A cached page bypasses PHP execution entirely. When an anonymous visitor requests that same page, the server hands them the pre-built version. It consumes 0 entry processes. Go to your WordPress dashboard, open the plugin repository, and activate LiteSpeed Cache. Activating server-level caching multiplies your site's capacity. Because anonymous visitors no longer occupy concurrent execution slots, your server can absorb massive traffic spikes without dropping a single connection. Sometimes your entry process graph is maxed out, but you know for a fact there is no human traffic spike occurring on your site. When this happens, go back to cPanel and open your raw access logs. We are looking for automated bot floods. Scan the log for rapid, repetitive requests from unrecognized IP addresses. You will usually see them targeting 2 specific files, xmlrpc.php or wplogin.php. Your immediate defense is to install a security plugin to restrict the number of allowed login attempts and completely disable the XML-RPC endpoint if you are not actively using it. Blocking this automated malicious traffic instantly frees up those trapped concurrent slots. It ensures real customers aren't locked out of your site by a fake traffic jam. Once your caching and security are configured, any remaining entry process failures are strictly due to irreducible dynamic load. This happens with actions you cannot cache, like logged-in WooCommerce shoppers completing a checkout. To calculate capacity, multiply peak visitors in a 10-second window by average page generation time. 20 concurrent shoppers times a 1-second load equals 20 EP demand. This exact formula proves if your tier, like the 15-slot bronze or 25-slot silver plan, can handle the load. If 30 people check out simultaneously on an uncacheable cart page, they require 30 slots. That will crash a 15-slot plan every single time, regardless of how well you optimize the rest of the site. Calculating your true concurrent demand removes all the guesswork. It gives you the exact mathematical proof you need to confidently justify an upgrade to a higher tier or a dedicated VPS. We have walked through the entire diagnostic journey, checking your specific error code, isolating the EP bottleneck in cPanel, eliminating dynamic load with caching, and stopping the invisible bot drains. The core truth here is that entry process limits control simultaneous fraction of a second events. They do not measure the total number of visitors hitting your site over a 24-hour period. Because of this, a highly cached site on a basic hosting plan can seamlessly handle tens of thousands of daily visitors without approaching the concurrency ceiling. By neutralizing the invisible drains on your system first, you ensure that you only pay for larger server infrastructure when your legitimate, irreducible business transactions mathematically demand it.